Have you noticed how we measure things without even thinking about it? Every day, we buy food by the kilogram and milk by the liter. So let's have a look at what measurement is. In ancient times, they used all sorts of ways to measure. Many people use the distance between their finger and the thumb to measure length. They called it a span.
But whose hand did they use?
In the Middle East, they used carob seeds to weigh things.
But what if they used other seeds?
The Egyptians devised a way to use the pharaoh's forearm to measure length. They called it the cubit.
Which was a big step forward. By using one pharaoh's arm, the cubit was always the same.
But overall, there was still a big problem. Whether we swapped things in the school playground or traded goods around the world, it was hard to compare like with like. Clearly, a new way of measuring things in the same way everywhere was sorely needed.
So, over 100 years ago, some clever people met and solved this problem once and for all.
Which is why, today, we all now measure things the same way all over the world. Let's have a closer look at what they came up with. Their big idea was to use nature to define measures. For length and distance, we use the meter. But what is a meter? A meter was defined by the distance from the equator to the North Pole on a line through Paris. They measured the distance from the equator to the North Pole, and a meter is 1/10 millionth of that distance. They then made a standard meter rod, which became the standard to be used everywhere. In today's world, we need even more accuracy. The clever people found a way to define the meter without having to use a meter rod. Today, we use the speed of light. Light travels from the sun at almost 300,000 kilometers per second and still takes 8.3 minutes to reach the Earth. Light travels at a finite speed, and in a wave form, it has a frequency and a wavelength. A laser light has only one frequency, which means that we can use a laser light to measure the meter. The same meter is the distance that light travels in 1/300 millionth of a second, and that is very accurate. We use the kilogram to measure weight, or to be more accurate, mass. But where does the kilogram come from? The clever people define mass in terms of the weight of water. 1 cubic centimeter of pure water was defined as 1 gram. 1,000 of these cubic centimeters of water, that is a cube of 10 times 10 times 10, is the same as 1,000 grams and defines 1 kilogram. And that in turn means that a kilogram is the same weight as a liter of pure water. Wow! We use the second to measure time. But what is a second? The Earth spins around its own axis, and each full turn we call 1 day and 1 night. 1 revolution divides into 24 hours. Each hour divides into 60 minutes, and each minute divides into 60 seconds. And that is how a second was defined, and we use clocks to keep it. Today, we have a much more accurate way to define a second, using frequencies. Remember that light is a wave that has a frequency and a wavelength. The frequency is the number of wavelengths per second. And if you have a wave with a specific frequency, we can use that to measure the second and therefore time. The clever people found that if you apply energy, for example electricity, to a cesium atom, it emits a wave at a specific frequency, and that can be used to define a second of time. The same principle is used by your digital watch, cell phone, and computer. They keep time by checking with the cesium atomic clock via the internet or cell network. And they keep that accurate with a small built-in silicon atomic clock. Let's have a look at electricity. If you don't have it, then there's a problem. So what is electricity? It is simply the flow of charged particles, for example, electrons. When the electrons flow, it is called an electrical current. Rate of electron flow, or current, is measured in ampere, sometimes shortened to amps. And the electricity that flows in your home is rated at 10 to 15 amps. But is all electricity the same? No, of course not. Lightning, for example, flows at up to 300,000 amps, which is enough to power 24,000 kettles.
And it is this greater flow of charged particles that makes lightning so dangerous.
And we define and measure ampere in terms of the number and charge of particles flowing.
Preview.
How do we measure temperature, which is a measure of warmth or coldness of something? The clever people decided to use the range from the freezing to the boiling point of water, which they call the Celsius scale. The boiling point of water at sea level is 100 degrees Celsius and freezing point is at 0 degrees Celsius.
Preview.
At 0 degrees Celsius, water turns into ice. And as water gets warmer, it starts to evaporate and turn to vapor, which is a gas. There is one special point where water can be liquid, a solid, and a gas all at the same time.
Preview.
This is just above freezing point and is called the triple point of water. The smart people now know that temperature is related to energy, and the faster the electrons move, the warmer the material becomes. The point where electrons stop moving also becomes the coldest point that you can get anywhere in the whole universe. This is absolute zero and is referred to as 0 Kelvin. Because 1 degree Celsius is equal to 1 Kelvin, absolute zero is the same as minus 273.15 degrees Celsius. The freezing point of water is 0 degrees Celsius or 273.15 Kelvin. Water's boiling point is 100 degrees Celsius or 373.15 Kelvin. Exactly 273.16 Kelvin is the triple point of water, which is also used as the second defining point for the Kelvin scale.
Preview. Preview.
Light is measured in candle power, and the light from a standard candle equals 1 candle power. This is called the candela. A candle shines all its light in all directions, which makes it fainter. Let's show you how to create a simple torch. A torch has a reflector on one side, so all its light is made to shine in one direction, which is why a torch looks brighter and why it is more useful on a dark night. Today though, we use electric current flow through a thin wire to create light. This is called a bulb. But we still use the candela to tell us how bright the bulb will be. The last unit describes the amount of substance, and it is called the mole. It is used by chemists to tell us, for example, how much fluoride is in your toothpaste. So how is the mole unit defined? You've been told that all things are made up of molecules and atoms. Charcoal, for example, is made of carbon atoms. So is diamond, which is also pure carbon. By the way, living things like you and I also have lots of carbon in us. The mole then is defined as the number of atoms in 12 grams of carbon. And it's big, very big, 602,214 trillion big. This is called the Avogadro's number. That's Avogadro, not avocado, which is a green fruit.